Hello everyone, in today's video, we're gonna recreate the chill effect from the popular movie K-pop Demon Hunter. I'll walk you through this effect using effects, keeping the whole setup fully procedural with no simulation involved. I will also cover the modular function, along with some tips and tricks for retiming your curve animation to achieve that perfect motion. It's a technique that I use a lot in production, especially on my recent project Sonic and Luna animation. It's extremely useful, lightweight, and easy to iterate on. So I hope you find this tutorial helpful and maybe pick up some new ideas for your own projects. So without further ado, let's get into it. Alright guys, so let's start this effect by create a new geometry container, and we can name this as setup effects trails, and we can untable this one, and let's dive inside. So first thing first, we need to create an object so that the trails can travel around. So in my case, I'm just gonna use a rubber toy, and then we can drop a node here and name this as ultra. So we can easily reference this node later on in the Solaris stage, and then we need to extract the centroid of the rubber toy, and then the variable should be detail. So we can have a point in the middle of this object, and then we can duplicate the number of points by using the point replicate node. And this node will help you to design the number of trails you will have in your shot. And in my case, I'm just gonna use 6. And for shape it should be sphere. And then we can add a little bit of noise to make it more interesting. So I think I will use a value around 7, and the amplitude should be 2. And we can copy some circle onto the points by using the circle and the copy to point. And for the circle, we can increase the division so that the circle have more of a rounded shape, and we can shift the arc type from close to open arc. And then right here we can see that all the circles are quite uniform, so we can vary up the circle so that it's more interesting. So first thing first, we need to randomize the normal so that the circle pointing to the different direction. So the attribute name should be normal, and the distribution for the normal should be direction or orientation. And now we can always change the seed here to control the shape that we want, and we can decide this value later. Alright, so let's do another randomize for the p scale. So that the scale is vary up between 0 to 1. And since this p scale is a float attribute, so we can change this dimension from 3 to 1. And I don't really want the circle have the p scale of 0, so we can do a custom RAM and fit it from 0 to 1 to 0.85 to 1. Alright, looking good. And then we can drop down a resample here, because right now the curve is quite low res, so we can give it more resolution by decreasing this length here, and let's chip polygon as subdivision curve so it will be smoother. And then we can tick on this curve U attribute, and this attribute is really useful for our effects later on, so make sure to check it on. And then we can give the circle each of the circle an ID. So instead of a class, let's do a curve ID, and we can visualize this attribute by a color sort, and the color type should be random from attribute. So let's do a curve ID here. So you can see that each circle will have a different color. Okay, so let's come to the most important part of this setup, is to create a system to control the animation for each curve. So let's do a variable here, and we can name this as any. And we can colorize it as the red color, and change the shape as a circle, and so we can easily spot it. Um, and actually, we can isolate only one circle, so we can easily work on it. And when we finish the setup for the effects, we can just bypass this blast, and this effect will work all of the circle. So let's visualize the curve U attribute that we have. So basically, this what this curve U say is an attribute that ranges from 0 to 1, and 0.5 is kind of in the middle. So 0 is uh, 0 is the beginning of the curve, and 1 is the end of the curve. So we can fit this 0 to 1 to the frame that we want. So for example, we can fit it to from frame 1 to frame 50, and just take the expression at frame, which means that the current frame to subtract the value, so we can have the animation growing from 0 to 1 right here. So let's do it. First, we need to fetch the curve attribute that we have by declaring a variable called gradient, and will be equal to curve, and we need to declare two other variable for the start frame, will be equal to in to CSI start frame, and another one for the end frame, CSI end frame. Alright, so let's fit this gradient from 0 to 1 to start frame and end frame. So let's do another variable. Let's call it new range, and fit a 1 for the gradient to the start frame and end frame. And as I said before, we need to declare a new variable for the animation. So we just basically take the frame expression, which means that the current frame, and in this case is 28, and we need to subtract to the new range. So we can export it as an attribute, and let's visualize. RAM from attribute any. So at the moment, the circles are on white, and it has a value of 1. This is because we haven't exposed any parameter yet. So let's do it. So the start frame should be 1 and the end frame should be 50. So you can see that we have a growing animation from frame 1 all the way to frame 50. So we can control the shape of the animation by fetch the anim to a RAM. So let's create a CS RAM anim and anim, and let's expose that. So let's do a step something like this. So we can have a little trail traveling around the curve. Alright, so in the reference, I think the trail is quite long, so we might need to extend that. So in order to do that, let's see what any what the any variable gives us. So we can do an test here to be equal to any. So let's check the value. So the test is running from minus 429 all the way to 0. and it will increase over the frame. So instead of just rely from 0 to 1, we can really fit it. So let's do it before this CSRAM, because after this CSRAM is always from 0 to 1. So let's do a fit here. Fit a 1, sorry, not a 1. So let's just fit the ending from 0, maybe 5 to 0 to 1. So we can see the trail is extended here, and this number will control the length of the trail. So I think for now the trail should be longer, so we can adjust this to like maybe 50, um, maybe 30. Yeah, yeah, maybe 15 is looking okay for this curve. Okay, so we can have the trail running for one curve, and this is a time to apply this anim to the whole curve. So we can bypass this blast. So at the moment, all of the curves are quite uniform. I mean, they are all start at the frame 1. So we can do some randomization for the offset to make it more interesting. So let's do a randomize. Uh, let's declare a float for the run frame, and we can do the run for the curve ID, which is the attribute that we declare from the connectivity. Um, and since this run gives us a value from 0 to 1, we can do a fit of 1 and fit it to the value that we want. CHI, maybe mean run frame, and CHI max run frame. And we can add another parameter here to control the set of it. CHI set. Alright, so let's export all of these parameters. And for the min frame, let's do -20, and the max should be maybe 20. And we can add this frame after this expression, run frame. So you can see immediately all of the curve are changing the offset of it, so it will be more interesting. So we can change this shift to control the randomization for the offset. And now we have the setup is working for our control. We can move on making the shape for each trail. So let's do a for each name primitive. And then we can specify the curve ID as the piece attribute here. Uh, so this set of nodes will help us to iterate our operation for each curve. And but right now the block and throw an arrow here. This is because the curve ID is not on the primitive level. So we can promote that after the connectivity by using the RCP promote to promote from curve ID from point level to primitive. And then we can test this by click on this single pass, so we can easily scrub to each curve. Alright, so next we need to isolate the white part of the curve, which means that the parts that have the anim attribute bigger than 0. So let's do a black node, and the group should be anim. Maybe we can delete the parts that has the anim attribute smaller than 0.05, and the group type should be points. Alright, so if I were to turn off this single pass, you can see that we successfully isolated. Maybe there is something wrong with this curve ID, because all of the curve is starting in the same frame, so we might need to check that. Oh yeah, let's not delete this original. This because the curve ID is still in this is still used in this anim wrangle. Alright. So next we need to recalculate the curve view attributes for this curve since they have been cut off. So if I were to click on this curve view and turn on the visualization, you can see that the curve views attribute are there, but they are coming from our initial curve. So let's do a resample here. But for this resample, let's not changing the resolution of each curve. Just turn on this curve view attribute to recalculate it. Alright, so now we can turn off the visualization and we can save the effects. So we can have a look at the reference. So the trail is kinda taper at the beginning of the curve and extended at the end. So we can easily achieve this kind of shape by using the sweep node. So let's drop it down here. And if by default it throws an error, this is because the surface shape is set to second input cross sections. So and we don't have anything plugged in into the second input, so we can just change it to ribbon. And we don't really need the field mask here, so we can alter this surface type to columns. So we have two parameters here. So the first one is controlling the number of curves. So I'm just gonna use 12 for these columns, and for the width, it just basically says the scaling. So I'm just gonna use 0.1, and we can further control the scale by using this apply scale along curve. So if I want to have this kind of taper shape, so I just need to drag this controlling point to the value of 0. So now we have the shape exactly like the reference. Alright, so second we can add some color. So in the reference, the color, the trail has a rainbow color, so we can kind of mimic that. So let's use a wrangle here. And before I type the code here, let's do the create meta import node. This is because we want to utilize the iteration attribute to make the offset for the color for each iteration. So let's name it randomize color here, and we can plug this block B into the second input. Alright, so let's type the code. So let's declare a iteration variable. So it will be equal to detail one. One is stand for the second input. We plug it right here, and the attribute we want to grab is iteration and 0. Alright. So we can do a randomization for each curve, and in order to do that, we need to use the so let's come to the UVs and attribute tab. So in the attributes, we have the BT code here. One thing that someone says that we can use connectivity, but the things with this connectivity is that the shape is changing over time. So you can see that if I want to turn off this connectivity and this randomize color, you can see that in the points here, the point is not consistent. So if you use this connectivity, the attribute class is also different if the curve is gone. So it's not reliable using this node. So instead of it, let's using this BT code, and let's open this randomize color again and the float random. So let's do a random for the BT code, and we can plus the iteration and some parameter. I mean a parameter for the seed control. So we need to close the parameters in here, and then we actually can set the color as CD will be equal to CSRAM color and then random. Alright, so let's promote the color here. So right now this is a float RAM, so we can change it to a color by edit parameter interface, and then we can change the RAM type from float to color, and then just apply and accept. So you can easily achieve the rainbow color by using this I believe the inferno, no, mm, infrared, yeah, the infrared color. So you can change the seed of heat here. So it has a different color for each curve. But in my case, I'm just gonna use my colors that I set. So if I come to this effect trails, the randomize color here. So I just gonna copy this one and paste it right here. But feel free to change the color to the color you want. Alright, so next you can see that when the curve comes to an end like this curve, you can see it's like stop for a while, and we can fix this by using a fade attribute. So we can create a fade attribute by using the curve view. So let's come to this part, and we can visualize the curve view attribute again. So we want to, so let's create a rectangle here to do a fade attribute will be equal to CSRAM. I will call this fade RAM, and then we can fetch the curve view here. So we can promote this. We can even visualize the fade attribute by using the color sort, and the color type should be RAM from attribute, and we can type fade here and turn off this visualization. So right now you can uh, kind of make the shape like this, so it will be black at the end and the start of the curve. So while I'm here, we can do an alpha. So the alpha will be equal to fade. Yeah, so you can see that when the curve comes to an end, it's just gonna like fade to the value 0 instead of like just suddenly stop. So we can make it even smoother by make it be spline, and maybe use the value so it will become more smoother. Alright, and one very last thing that we can improve for our effects is the length variation. So if we take a look at the reference here, you can see that the length is different for each curve at the end of the curve. So once again, we can utilize the BT-code attribute that we got from the sweep again, and just convert it into a randomization, and then fed it into a curve node. But just to keep in mind is that the curve node is expecting a primitive attribute, not the point attribute. So we need to promote the particle from the point level to the to primitive. Okay, so let's do a primitive value to do the conversion. So let's call it randomize length. Okay, So let's declare a float variable called length. So it will be equal to feet of one run the pt code, and then we can plot it with a seed parameter like the last time we did before, and we can fit it to 0 and maybe 0.15, and then we can export it as an attribute called first field be equal to length. Alright, and finally you can just need to take this curve and plug it right here, and instead of using this constant value as 0.25, you can just change it into an attribute, and the attribute that we want to specify is the first field that we said before. So you can promote this parameter for controlling the seed, and we can reset the cache path and take a look at the variation. So right away you can see the variation here, and you can always change the length to the value you want, maybe 0.05 now, and we can change the seed to whatever value that you want. Yeah, looking good. And then one thing you can notice about this effect is that the trails ends kind of quickly. It will be ended around like frame 60 to like 70, but we want the trail will be happen for the whole frame range. So we need to extend that. So if we were to click on this ending rangle here, and we have from frame 1 to frame 100, so let's type 100 here, and you can immediately see that uh, the length of the trail will be shorter, and also the speed will be slower. And I think it's probably one of the drawbacks of this triangle here is that you cannot control the speed and the length of the trail separately. So we need to create another node to be responsible for the speed, and we can use this triangle here to initialize the length. Alright, so let's set this end value by 250, and we can tackle the extension of the effect first. And one of the best solutions I can think of is using the modulo function. It's basically you can repeat this effect for every certain frame. So to do that, after the test attribute, you can just use the any variable will be equal to any modulo by the frame rate that you want. So maybe week one the effect will be restarted for like every 70 frame, so which means around like 3 seconds. So if you scrub to the timeline now, you will see the effect will be no longer ends around frame 60 anymore. It will be traveling around the character infinite frame. Alright, so let's address the speed. We can actually adjust the speed by using the retime node, and the retime has a really cool function inside this evaluation mode. So you can just change it by speed and adjust the speed that you want. So maybe 2.5 for this one. So, and you also need to increase an input and output frame rate to really high for compensating this speed. Um, so let's just type really high value here. It doesn't matter how high is this because our effect is infinite, so it's okay to typing a really high value here. And you can see that the effect will be much faster than before. Nice. And one little tip here, if your director says that the effect will be in slow-mo, you can just type like 0.1 here. Uh, let's wait for the effect to be okay. So you can see that the effect will be slower, but you will see some jittering here. This is because of the substep, so you can easily fix this by increasing this substep right here. So maybe use the value of 100, so the effects will be much smoother. Nice. And then just set this speed value back to 2.5, and we can prepare some attributes for this effect to be rendered. First of all, we need a V attribute for the motion blur. So since the effects are still in curve, we can utilize the tangent of the curve for the velocity. So just use a polyframe node, and then we can take off the normal name here because we don't need it. And for the tangent name, instead of the tangent u, we can use the v here, and now just turn on the visualization and this icon, so you can see the visualization here. It seems to be correct. Nice. Alright, so one another thing you can improve for this face is uh, increase the resolution or the point number. So you can use the point replicator, and it will be exploded. This because the uniform scale is too high. And first of all, we can copy the source attribute. So all of the newly created point will be inherited. All of the attributes like CD or alpha. And then for the shape, we can decrease this uniform scale to like 0.006. So it will be much smaller. And then for the shape, you can use sphere here, and we can also use the velocity that we just created for this option. So all of the point will be stretched to each other, so we can fix this like substrat issue here. So let's just increase the scale to like 5. Yeah, maybe even more. Okay. And for the quantity, it really depends on you, but I think 100 is like it's still too much, so I will decrease this to like 30. Alright, looking good. And then we can finally declare a p-scale attribute here. P-scale will be equal to parameter p-scale, and then maybe 0.0, maybe, yeah, this value, and we can adjust this later if we need it. So we can name this to set p-scale, and then finally we can use an attribute delete to delete all the attributes that we don't want. So maybe we just delete not selected. To select the attributes that we want, we need alpha, CD, P, V, and P scale. Alright, so let's use a node here, and we can name this to out effect trails. Alright, so finally we can get to the Solaris stage. So let's just get outside and create a log network, and then dive inside. And first of all, let's import the camera into the lognet. So we just need to choose the object that we want, and in this case it's cam1. Just accept pattern, and then we need to import the repertoire here. So let's create another sub import and connect together. And for this sub import, we need to reference this node that we created and paste it into the sub path. And we successfully imported the camera and the repertoire here. And one problem with this sub import is that it doesn't include the material. So since we didn't do any modification to the rubber toy, I think we can just use the rubber toy made by the Solaris. So let's plug in here instead of this sub import. So we can have all of the material by default, which is good. Nice. So let's get rid of this sub import, and we can create a merge here. And this merge is for most this rubber toy and this effect we're gonna create in a minute. So let's create a soft import to import the effect. So let's get our effect trail here. Just copy and paste it in the soft import. And then we need to create the material for this effects. To do that, let's create a material library. And for this effect, I just want a emissive material. So let's create a camera material builder, and we can name this to matte emissive. Let's dive inside, and then we can turn off this base because we only want the effect to be emissive. So let's import the color from the uh, effects to the log level by using the USD print parameter. And the attribute for the color is CD, but in storage it should be changed to display color. And since the color is a 3 vector, so we need to change the signature from float to vector. And we can plug this result to emission color. And we need to increase the emission to like maybe 3 for now. And then we also need to import the it's not generator, it should be USD print variator, and we need to import the alpha, and alpha is not this name, it should be display opacity, and the alpha is float, so it's fine. So we can plug the result into the geometry and the opacity. Alright, looking good. And get outside, we can and now we need to assign the material into the effects. So let's use the assign material, and we can drag the material into the material part, and the primitive should be the 0.0 here. Alright, so let's merge everything together, and we don't have a lines here, so we can create a camera physical sky and turn on the exposure and increase it to like maybe 1 for now, and we can check the render by maybe tick off this option first, and then switch into the camera XPU. Okay, so we can see the background here. We can turn off this option, the renderized geometry, so it will be a little bit faster for our preview. Alright, so let's build it into our camera. I think the P scale is a little bit high, so maybe I can hold this screen, the viewport, and then get inside this setup effect trail, and further decrease the P scale, maybe 0.001. Yeah, looking better. And then we can actually use a velocity here that we created inside the low plate by using the render geometry setting. And then we can for the primitive, we need to drag the sub import 0.0 here, and then we can scroll down to find for the maybe above, yeah, this option here, just set or created, set or create, and we can use the velocity blur for this option. So we successfully created, I mean use velocity for this effects. Alright, from here we can create two render buses for this sort. One is only for the rubber toy, and one is for the effects with the rubber toy but as a matte. So let's do the effect first. Let's create a render geometry setting, and we need to drag the rubber toy into the primitive here. And for the hold down mode, we need to set or create and set it to matte. Okay, so let's do a camera render setting, and we can specify the part that we want to render here. So in my case, I'm going to use the job variable render $os $os dot sf4 dot exr, and the camera we want to render is this one here, and we can set the resolution mode to manual and use a 1080p. Alright, and you can even use a filter here, the denoiser here, to make the effects more smooth. Alright, that is for the this one, and you can use the USD renderer and uh, render specific frame rate and just render this one. And then let's take care of the repertoire pass. So for this one, we can use a render geometry setting and set the effect to be primary, so the effects will be invisible, but it still illuminates the lights onto the surface of the repertoire. So for this one, we can drag this pointer over here, and then for the um, render visibility, uh, we can set it to invisible to primary phantom. Yeah, so you can still see the lights illuminate into the onto the surface of the robotoid. And then you can also use a camera render setting. I forget to name it, so just gonna name it to FX trails. And for this one, I want to use the robotoid. Since it's user $OS, so you don't need to change anything here. So just use another UID render off, and you can render two of these passes out. So let's do it. Render, uh, yeah, render to this. Alright, so this is basically how to do the spatial effects, and there's still quite a lot of room for you to improve these effects, like changing the seed, or like increase the scale, or instead of this circle, you can use some shape like the long lines right here. And so yeah, thanks a lot for watching this video, and I hope it's useful to you. Just feel free to grab the project on my Gumroad and ask me any questions that you don't understand. So yeah, I'll see you in the next video. Bye.